So hi everyone, I think we can start. So on behalf of Ideas, I'm very excited to have you all today. Thank you for joining us for our weekly webinar. Today's topic is the machine learning CrossCloud. But before we jump into the topic, let me just briefly remind you what is Ideas, what we do, and why we do that. So again, big thanks for everyone who is watching us online, and for those who are watching the video on YouTube. Hope next time you can join us. So what is Ideas? I hope you can see my slides. So IDEAS is International Data Engineering and Science Association, IDEAS. We are not non-profit organization, and our mission is to bridge the gap between academia and industry. So briefly, we are a big organization. We are very excited about big data, machine learning, data science, and also blockchain. And we want to share this enthusiasm with others. That's why we are bridging the gap. We are connecting this academia and industry. This is our roadmap. We started in 2016. We started as a small conference at USC campus, but then we started to grow up. And right now we hold conferences across the country in New York, Dallas. We also do different conferences about blockchain, hackathons, and meetups in different universities. This is a briefly product gallery. This one, the first one, so-called conference at USC. Not a lot of people, but then we started to grow up. This is New York Blockchain Leadership, and this is Chicago Blockchain Leadership. This is so-called conference in Pasadena Convention Center, and this is the last one, which happened in Los Angeles, the big one, Los Angeles Convention Center, so-called conference. A lot of people showed up. We had more than 300 speakers, and a lot more to come. So yeah, as I told you, we also have different meetups at different universities, such as MIT, Harvard, UCLA, UC. So if you haven't had a chance to come, just make sure next time you can come. And this is our website, ideassn.org. If you have any questions, go ahead and ping us through the email, conference@ideassn.org. And also have pages of Facebook, LinkedIn, and Twitter. And if you missed our webinars last time, we have all the videos on YouTube. This is the QR link for our YouTube channel. And let me just finish my presentation on this and go ahead and introduce our speaker for today. Today's speaker is Andrew Zhang. He's an IBM Watson Cloud advocate. He's IBM Watson engineer. He has many years of experience in cloud, analytics, machine learning, blockchain. He also advises and advocates enterprise and startup companies on emerging technologies and implementation of practices. So Andrew Zhang is like a frequent speaker about Watson, deep learning, blockchain, and he's also in the process of writing a book. So welcome, Andrew. Let me just pass the whole presentation to you. Andrew?
Yes. Yeah, I just opened my speaker.
Okay.
So should I share my?
Yeah, go ahead. Screen? I'm gonna stop sharing my screen.
Okay, good. Do that. Okay. Can you see my presentation slide?
Yeah, I can see your screen. I can see it. Thank you.
Okay, so how do I minimize this? Okay. All right. Thank you everyone for joining today's session. My name is Andrew Zhang. I work in IBM as a cloud and data AI engineer. Let me go for the next slide. So today's topic, I have a couple subjects to touch on, but the main topic I want to give is on scale machine learning CrossCloud. So a little bit about myself. I've been with IBM for about 3 years. Started with working on Hadoop and Spark big data platform, both on-premise and on cloud. further on, I get into data science and machine learning. Mainly, my focus is helping enterprise customers to solve their data challenges. So here is the agenda. I will quickly touch on what is machine learning and the current state of machine learning. Then I'll share some of the challenges in enterprise with scaling machine learning. That is pretty much about what I have done before. But this year, I've been getting into the space how to run machine learning across cloud. So I will share some of the content over there. My specialty for focusing on the client are in the public sector and healthcare and life science. Public sector including local and state government, universities, and life science is kind of pharmaceutical, biotech. Healthcare is like health insurance company, hospitals, and providers. So let me get to the first topic. I think many of you probably have seen this chart already. I don't want to bore you, but to set a stage, AI is nothing really new, but been around for since 1950s. It's about the techniques. Any techniques can enable computer to mimic a human being to see, to listen, and to speak. Machine learning is a subset of AI. It's really about enable computer to learn from data, really using statistical model. But things like that has been around since 1980s. And deep learning came up or taking off since 2010. It's really about using a particular method in machine learning called neural net to learn features from data. So as many of you already know, machine learning, traditional machine learning require manual feature extraction and engineering, and extract the features from unstructured data is very difficult. This chart shows you some of the methods in machine learning. Traditional machine learning has been around. Therefore, supervised and unsupervised learning depends on whether data is labeled or not. But further on, there are classification, regression, clustering, dimension reduction, many algorithms or techniques underneath for the matter of 100 or 200. So that is a pretty complex, space in terms of machine learning techniques. Moving to deep learning, one of the important feature of this, one of the important capabilities among deep learning is can automatically learn features in data. Although it's very debatable nowadays, the limitation of deep learning, but it's justified that deep learning has achieved something we haven't seen before. This chart will show you traditional machine learning versus deep learning, particularly neural net from small neural net to deep neural net. The performance of the methods are scaled pretty fast over time with data increased. So that is what we understand where we're coming from. So why deep learning become so popular recently? I think that for one, deep learning now can be more accurate than humans for special tasks, such as classifying images doing language translation or voice recognition. The other very important fact is we now have a special hardware. Special hardware now are also very much accessible on cloud to train large amount of data in less amount of time. That namely GPU and FPGA and Google come with the TPUs. We also getting a lot of data thanks for mobile social internet. We have a lot of them. But to be successful in a machine learning project, we need access to large quantity of data and also large quantity of labeled or classified data. This is very important. On the academic side, there's research on transfer learning and in helping us to train deep learning or machine learning models with less data. And that is in response to the challenges in many organizations we are still lacking of data. So let's talk about the enterprise. So Google actually published a paper about hidden technical debt in machine learning systems. Many advancements in this AI technology is coming from Google, and they're implementing one of the largest AI systems in Google itself. They have learned a lot over there, so they understand the complexities in building a large AI system. So they look at this AI system is not just the algorithm, which is the black box over here. That's probably 5% to 10% of all the heavy liftings you need to do to build an end-to-end solution. That including, how do we collect data and how do we clean data? How do we understand data and extract the data features? How to operationalize the system by giving infrastructure access, managing resources, monitoring productions, and overall, how do you do deployment from development, QA, and the production systems? So over time, my observation by working with many customers and clients, I see many companies, particularly traditional enterprise companies, are facing several key challenges. For one, data are still siloed and very difficult to access. That is a complex question to tackle, both from organization perspective and also from technology perspective. Many organizations are struggling also in learning how to handle unstructured data, learning handle effectively working with external data. So that is one of the challenges for enterprise. Second, govern the data, secure the data in a proper way, and getting data indexed, labeled, tracked is also very challenging. For a very large company, usually they have 50 to 500 systems. To getting all this data cleaned and centralized, one of the are very challenging. It's very challenging. And if you have heard of this data lake concept for the last few years, many of these projects just failed. Third, on one side, the company are looking for data science skills, but they have hard time in finding the right people. On the other side, universities and online universities are training a lot of professionals or data scientists, graduate students, these two markets somehow still have a gap to meet each other. Last, the tools and infrastructure here are also lacking. We need to enable people to learn fast, fail fast, but also we need to make the job easy, make data simple to work with. I won't bore you with details over here. This is one of the approach we in IBM trying to solve the problem. It's not just IBM. I think most of companies are trying to make this pipeline or workflow easy for users, for connecting data source, for both structured or unstructured data. It's a very, very big effort. Having data cataloged and organized is a very boring job. So sometimes people won't be able to invest time and the capital there because it takes a longer time to realize the value. If you don't prepare data or refine the data, then it's hard for you to train the machine learning model. And that's the big effort need to be invested for organization. Now comes to the part of training and building models. There's several important trends over here. A key word here is companies or vendors are trying to democratize the effort to train or create machine learning models. That includes both, for programming side and also from, visual side. There are many popular tools available, such as open source tools or proprietary vendor solutions. There are hardwares like GPU becoming available. So these type of platform and tools need to integrate this new type of technology. Scale machine learning models automatically is also important and also involves some of the effort to understand the complexity of the environment we work with. Finally, we need to monitor and productionize the model deployment and manage that in a more robust way. So this effort, what I have been seeing industry-wide, people are making a lot of effort in investing in this space, both from client side and also from a solution side. But some of them are successful, some of them are not very successful. I'll explain a little further in the following slides. This is the way IBM Watson Studio has been built. At the bottom, you can see we are building a scalable modern infrastructure based on Docker, Kubernetes, and the GPU. On the middle, in the middle tier is a platform as a service engine running for different type of frameworks for machine learning and deep learning. As you all know that this is a very fast moving space, incorporating this variety of technologies as quickly as possible is not a trivial task. Finally, we know working in an organization, this is a community of different people. They are familiar with different type of tools, such as Python notebook, RStudio, or some other visualized tools or development tools. Let me move further. I won't have time to show you all the capabilities within this particular platform, but I will mention a few. So usually when you do train a visual recognition model, image classification can take you some effort to write a notebook, important import the proper libraries and train many times. Ultimately, you can claim you have a model useful, and that requires some type of skills for data scientists. But nowadays, you can train a custom classifier using drag and drop and doing that pretty effectively. The key thing over here is you need to have the right data, images, say variety types of cars. Sometimes you need 50 pictures. Sometimes you need 500 pictures, and depends on what type of goal you try to achieve, what type of accuracy rate you want to get. We're also developing tools to do drag and drop. You know that the older generation, we have like a wizard. You can just insert data, ingest data, then pick up the model and run training. Now these tools are getting better. You can add a variety of nodes over here to say do record operation, to filter operation, pick up multiple models and run multiple training, and then persist the model, evaluate the model and such. And all these can be done just with drag and drop. And it's integrated with cloud platform with latest infrastructure technologies. We also have a model builder for neural net, which means if you want to train a machine learning model like CNN and something, we can create a training definition here and then pass to experiment to let it run on the cloud. Again, this is something easier than writing notebooks. But again, you need the foundation knowledge of what is neural net and the general practice to train neural net. But this is not something people need to learn for, say, 5 months. Maybe this is like some effort people, if they do intensively, maybe it's 3 to 4 weeks effort to get something, up and running with a good understanding end to end. Because usually these tools also provide with some examples. So we covered about what is machine learning, in enterprise. As you all know that, there are many vendors out in this space on cloud. They all provide machine learning on cloud as a service. These are categorized in 2 main categories. The first category is how do you train model? It's kind of the core pieces to getting data in and then run different algorithms and evaluate it and then deploy it. So that is one set of tool. The second set of tool is consuming, is running prediction based on the base model trained by these, big vendors like Amazon, IBM, Google, Microsoft. These services are getting richer and richer every 6 months. So if you want to do something little bit, say, facial recognition, you can easily find from all of them. But the accuracy rate may not be as good as what you expected, depends on what you're looking for. But again, this space is going to offer alternatives for people to do everything by themselves. So that is what's happening towards today or maybe last year. I've been seeing, on the cloud side, the vendors are investing many a lot of resources in the space and by building these tools and make it easy for people train models and then deploy them and even consume them. So let's talk about how to do this in a cross-cloud environment. again, I'm going to just share my personal view from IBM perspective, but this is pretty much in general happening in the industry and the other companies. So if you look at the infrastructure landscape from the top, you have some vendors. These are not big vendors. These are like open source vendors. They come up to play with. And at the bottom, you see they're purely open source players, not companies. These are some of the tools available. So I want to introduce you some foundation building blocks for running machine learning on cloud and further on CrossCloud. One important piece is called Docker. Docker is a container technology sitting on top of the VM or host operating systems. The other piece is called Kubernetes. Kubernetes is a technology or platform for you to manage containers, but manage a large number of different type of containers to work together. So if you look at this particular chart, this diagram, it represented some of the key modern technology stacks for running different type of workload. At the bottom, you have object storage and the database versus, if you coming from Hadoop or big data space, there's HDFS or traditional databases. Here we have object storage and open source databases, right? And on the top, very top, you need to run your business logic or programs, whether it's a web application or backend systems. That's the code you generate for your business. But you also have two layers here. One is called a middleware. One is called orchestration. The middleware can be big data systems or machine learning workload or serverless workload. I call them workload is based on the nature of the computation they're doing. Nowadays, Kubernetes is becoming a clear choice for most of the vendors. I'm not talking about all the individual companies or clients, enterprise. I'm talking about vendors like Microsoft, Google, IBM, or Amazon. It's getting very clear. Kubernetes is going to be the next choice for orchestration. Kubernetes has been there for quite a few years since open sourced, but only over the last year or two, it's coming to become a standard. And that actually helps vendor to make investment and move in this particular technology direction. That is also going to drive how the workload will be moving on the cloud and the cross-cloud. So let me introduce something called CoopFlow, which is also on that infrastructure chart at the bottom for open source. This actually help me to illustrate you this technology, how it's going to be used. So if you think about doing machine learning that require a whole full pipeline with building model at the core, Kubernetes-based CoopFlow is trying to solve a problem in this way. If you look at the top, when you build a model, you can build a model by running the process on your laptop, and you can do this on a particular server in your data center, and it can be doing this on a cloud, which is public cloud. But if we bucket this in two ways. Then at the bottom, which is the hardware, accelerator, OS driver, and runtime, we can let Kubernetes manage this. It's going to be abstracted, hide it for you. But CoopFlow can manage from model, building, UI, tooling, and framework, and the storage perspective. Conceptually speaking, this gives you a way to rebuild or swap out all the things you have done before by building an end-to-end machine learning stack. So what it comes with it? So the key word here is cloud native machine learning. It comes with it is Kubernetes has become the hybrid solution to deploy complicated workload. I mean, Kubernetes was used to start with other purpose. But over time, now we realize this particular framework can be generalized for any type of workload, not just for public cloud, but also for hybrid cloud, not just for mobile application, web application, but it can be used for analytics workload and also for machine learning and AI. If you look at the details, the three important components. Of course, you need a way to manage interactive Jupyter notebooks. You need to have a way to interface different CPU and GPU. You can adjust the CPU and GPU sizing just with one click because TensorFlow, this custom resource, allow you to make it very easy and simple. And also it comes with a container. The container will be virtualized and sitting on top of Kubernetes. And if you deploy something inside here, and you can move to another Kubernetes environment with just a click. So far, I covered a foundation of a new technology trend happened just probably, to be clear, probably just the last 6 to 9 months. But I think this year, all the vendors are coming initiatives moving to this direction, which is a cloud native hybrid cloud environment for machine learning AI, both for cloud perspective, both from public cloud perspective and also private cloud perspective. Let's talk about the deployment option with Watson Studio, which is the tool I've been working with for the last 2 years. Initially, we have a public cloud, which is fully managed IBM Cloud version. And this year, we roll out a desktop version just a few weeks back. Now we have a version for local, which means a cluster can be sitting on top of Kubernetes, can be deployed to any other cloud, public cloud per se. And we also come up embedded Watson Studio into a tool, into a new platform, end-to-end platform called ICP for data. This can be deployed into any data center in enterprise environment. I won't go for the details, but this is a very high level how it looks like. At the bottom, this particular Watson Studio or ICP for data, this particular cluster environment can be orchestrated, abstracted, sitting on top of different cloud. But on top of it, we can extend or customize the environment with any particular type of workload, which means you can swap in and swap out. This is the high-level architecture about what's sitting under Watson Studio to train a machine learning model and deploy it and manage it end-to-end workflow. So why we need to do the machine learning cross-cloud? So for one thing, I have seen that many enterprise customers are still sensitive in moving data to public cloud, given we know public, security breaches every week, on media. So sometimes we need to train machine learning with sensitive data, but we need to train them on premise, but we can deploy them on public cloud. Sometimes we want to train them on public cloud because we have a very legacy infrastructure in the data center. We want to use a high-end scalable GPU in public cloud. Then we train on public cloud and move them back to on-premise. Sometimes we want to take advantage of the public data on public cloud and then train on public cloud and move them back. The key thing here is it's now getting clear. People feel comfortable and safe. They are protected that they can move the workload up and down and vertically between different vendors. Before that, it wasn't totally possible. So this is a platform we're building, which is kind of like a box you can ship to the company of enterprise client with all these capabilities. We're sitting on top of Kubernetes and the modern cloud native microservice infrastructure. The key here is moving compute and the algorithm to data. For the last 5 years or even 10 years, many companies are doing this wrong because we want to move data. But moving data is very expensive and it's very risky. And because of that, many of these projects failed. Now, we realize there's a possibility we can just move the compute engine with the capabilities towards data. So if you look at this chart, at the bottom, all the companies are having Kubernetes engines built up. IBM had 3 versions. One is private cloud called ICP. One is public cloud called IBM Kubernetes Services. The other one is through the Red Hat acquisition called OpenShift. The other vendors from Amazon is EKS, Azure Kubernetes Service, and the Google Kubernetes Engine. So these are all the key players in Kubernetes space. IBM had a multi-cloud manager to manage all the workload sitting on top. And on the very top tier, if you understand the enterprise just have these 4 or 5 buckets of workload: modernized application, manage data, transfer business, and integrate the services. So hopefully this type of framework can make enterprise clients feel comfortable to move into a more mixed hybrid cloud environment. And that is also the foundation to build for machine learning. As we pointed out before, machine learning is not just machine learning itself, it's many other pieces coming together. So given interest of time, I will just quickly go through a couple healthcare AI initiatives. Over the last few years, we have seen some of the deep learning effort done in healthcare. Recently, I have attended some events and meeting with Google and Amazon, Microsoft colleagues. It's very interesting to see this space still evolving and moving very fast, both from big vendor like a Google, Microsoft perspective, but also many startups. I won't go for some details here, giving short period of time. So what I want to say is many medical and health clinical AI applications are on the horizon. they're popping up all the time. But machine learning models are as good as the data you can get. So if you don't have a good data, then garbage in and garbage out. There's still a lot of challenges with the social, economical, and the regulatory challenges. One of the key problems is we don't know we have enough clinical evidence with the AI project or AI application in healthcare. So my suggestion is ask a question to doctors. So that is my final slide.
Great, thank you, Andrew. Thank you for your presentation. It was very wonderful, informative, and interesting. I especially like the architecture and the flow you explained really easy. So we appreciate your effort and your time for today. Thank you again. So meanwhile, everyone preparing the questions, there is some acknowledgement from Suresh. Yeah, thank you. Really very simple and easy explanations about. And also some attendees asking if the slides are available offline, or maybe you can post the link of your slides somewhere on the cloud. Is that possible?
Yes, I will follow up with this with you. Yeah, I'll send the link afterwards.
Okay, great. There is a question from Hemant. Are there any projects, AI and social media?
Are there any project AI in social media?
Yeah.
Yeah, so it's really about where you want mining the data, right? So there are marketing companies looking on social media to understand, you know, if they post, you know, marketing information on social media, how people share that, how people view that. They're also brand tracking how people talking about them. Say university want to know, you know, how students mention about their university and getting that information as feedback. Yeah, some people tracking some sentiment, you know, on a particular topic or product.
How about like scanning particular terror in social media, etc.?
A particular social media. Is that a question?
Like particular terrorism and social media.
A particular. Sorry, I didn't hear you clearly. Can you repeat?
Okay. So the question is, how about like scanning particular terrorism, like everything terroring in social media?
Oh, okay. Yes. So there are government agencies and local government also use that as a supplementary tool to help them to getting notified for, you know, say criminal and event. It depends on depends on how the agency try to integrate the multiple channels together, because they have phone system, they have website, they have chat, they have social media, and depends on how they publicize that channel for people to take advantage of.
Okay, that's great. Hope this answered the question. Another question is, okay, are you seeing AI in healthcare other than just image analysis?
No. Yeah, actually, what I just mentioned is some of the key advancement recently been mostly discussed in these big vendors and solutions in hospitals. But you know, there are many other researchers say natural language processing is also important because most of the organization has text data, right? Not just images. So image is just one of them.
Okay, great. Jaita, I hope your question is answered. Another question from Suresh. what is the best way to catch up with machine learning and deep learning?
That's a good question because it's even challenging for myself. I think it is you need to use a combined method to learn. For one side, you need to go something a little bit deep, but just as deep as enough. But sometimes you need to go for broad. So you need to find a way to just scan something very quickly. For example, we have some tools you can learn something, understanding how to build a machine learning pipeline end to end, how to evaluate the model. But for coding side, you also need to do something, on a notebook and with a variety set of data. You also need to learn math. I guess depends on your goal, but pattern those similar to your background and learn from them. The other thing I will say is, as I mentioned, these tools are getting better and better. Try to take advantage of these tools. You can learn faster.
And there is another question from Corey. Where should a person begin if they're looking to switch the career and want to start learning how to become a data scientist? Any resources you would recommend, like courses and books?
I tried a few. I know that Andrew Ng has a class lately opened called AI for Everyone on Coursera. That's for non-business and not non-technical people. For people who want to learn that with a deep data scientist, you need to take something like deeplearning.ai and learn all the mathematics aspect of it. But for someone who want to be just a practitioner and use it, learn as enough as possible, I heard of that a fast AI is pretty good because you can take that class pretty quickly and put that in use. And also they teach in PyTorch.
Okay, great, thank you. Hope Corey and Suresh, your question is answered. There's another question of the topic. So since deep learning is black box method, how can we understand its inner working to improve it?
I heard a lot of debate on this, and I think we are still in the territory try to make this better. There's some techniques try to understand a small unit in which way the model derived from, and then tweak the result a little bit, tweak the input a little bit and see the outcome. So there's some techniques in doing it, but it's not easy and perfect. I would say it's a debatable field. Depends on which domain you go with. If the industry you work with require a deep explanation of these models, then you got to be a little careful to use this method.
Okay, yeah, great. Another question from Danai Shankar. Where does a data scientist expertise be utilized in this automated flow?
I didn't hear the last part. What do the data scientists utilize in what?
In the automated flow, in the flow of this automation. Yeah.
I don't know. I totally understand the question.
So,
but
basically, how does data scientists can help to be useful in the whole automation stuff? Yeah, I think the question is something like that.
Oh, okay. Yeah, what I found out is they all come from different, I think from different shape or environment. Some environment require you to contribute from the business perspective. Some require you to contribute in the data and getting data. How do you drive the process end to end, and then create a data pipeline and getting feedbacks and generate new business model from that perspective. I guess that's every dimension you can look for, but you need to target something in some quick wins. What we found out is many of these projects, people are looking for quick success. If you cannot demonstrate something quick, then that is going to be challenging because the pipeline or workflow is very long. You need to somehow figure out a way to illustrate in your particular steps, 3-4 steps, you can drive something they haven't seen before.
Okay, and another question is, how can models be improved and new academic techniques be implemented in this tightly knit data pipeline in what sense?
I heard of, or I've been observed on these academic areas, they come from two streams. On one stream, they're looking for research and try to make advancement over there. On the other side, they're a little bit different than the real world. A real world, you come with this data issue, regulatory issue, getting support for funding the project because you need to have a meaningful business case. But in academic environment, sometimes it's just like for research interest. I think it comes with both sides have their own benefits. In research side, you have more freedom in pick up area, which you can get into some of the latest research result and learn and utilize those research. But in real world or in company enterprise, your goal is actually make money, save money, reduce risk, or change your business model. So that is a different objective, which you need to be mindful.
Okay, thank you. Hope, Danai, that the question is answered. Another question from Vishal. How important is distributed computing for performing machine learning on large data sets?
When you say large data set, it's relatively speaking, right? So I think if you have it require you for large data set, that's come with some, I mean, cloud environment that give you elastic computing resources to do that. But you can research on this type of effort. There's a benchmark about people doing variety of machine learning algorithms and workload with benchmarking. You kind of will have a good idea how much you're going to spend in building something like this. For one of these medical image project, I saw that just computation-wise building one model takes like $4,000, and that is something for a lot of people wouldn't be possible. But if that's what it takes, that's what it takes. But you just need to understand it before you dive into it.
Yeah. Another question from Vishal too. What is the preferred language choice for deploying production level data science applications?
I know that for most part of production system, mostly people are using TensorFlow, just because they've been there a long time, and the TensorFlow offer a lot of flexibility, interface, large communities. But for academia, people are using PyTorch because it's kind of clean, clear, easy. So I think over time, everybody needs to watch on this space a little bit, Google it, YouTube it, and learn the advancement in this space. And I think this is we're still early in the game to know which one is going to be end up with, because yeah, in 5 years, things can change.
Yeah, that's true. So another question from Vishal. How do you recruit freshers? Are they expected to have a research background or the projects and solid fundamentals enough?
I missed a couple keywords.
So
Resource?
I think the question is, how do you recruit these freshers? So are they expected to have a research background or just the projects and solid fundamentals, like the programming is enough?
Oh, okay. So I think for most organizations, they already have people with domain knowledge and project experience. Many organizations don't have staff in data scientists, not because they don't need them, they just don't know how to use them. And sometimes they don't have a confidence to start a project without knowing that the outcome, because as people understand, not necessarily all the project will be successful until you have a deep understanding of the data and what you can derive from the data. But that upfront investment need to be happening first before you know you can get an outcome. So that's like a catch-22. So I think it takes number one, for the organization need to have a leadership in understanding what it is and how to do it. And that's why Andrew Ng had this course, AI for everyone. So after he teaching machine learning and deep learning for many years, he realized the important people he need to teach is not just data scientists, it's the business people. If they learn how to do it, then they can hire more data scientists.
Okay, Vishal, I hope your question is answered. There is another question from Vishal too. What is the foolproof method to choose the model? In the sense, how do you decide that your model is indeed good or not for the particular task? Does the industry have any?
Right.
Okay.
Right. Yeah, I got you. Okay. Question. Yeah. So this is a very much. There are people saying, some of the traditional machine learning model just do the job. XGBoost has been doing pretty good job, and random forest has been doing pretty good job. But some people want to achieve something, they have to use deep learning. I think that's one side because of the nature of this algorithm and the model. The other side is a personal preference. If you have done something with a particular set of data for many types, you are good on those. You can almost guarantee by looking on that case, knowing the outcome, what you can produce. That takes experience. You don't have that experience, you don't know. I think that's, if you really don't know, you have to just test and compare. You have to just build a few and test a few. The worst case, you just need to get the new data and test the boundary to see that the data has a bias, is that overfitting, or as good as enough until it breaks, right? But you need a way to recover it. It's not like that model works in a confined state or environment. If you need to deploy this model in the ICU for emergency purpose, then I don't think you can even easily deploy it without enough testing and confidence on that.
Great. So I hope, Vishal, we answered your question. The last question is from Hammond. Are there any presentations which will show the return of investments comparing to CapEx and OpEx to upper management like CIOs, CEOs, and which is non-technical?
Actually, it's case by case basis. You have to, because as I mentioned, it's not just, there are many dimensions to say this is a successful project. it's kind of make money, save money, and reduce risk, increase efficiency. I think the key, most of the quick wins, like doing some automation, replace some of the human labor intensive work that you can show manpower, saving, right? Some of this model you wouldn't be able to deploy it, then it's hard to say. You can do some A/B testing to see, on this particular set of segment or marketing, you predict result as X. On this one, I create a model and I do Y. And you test in different settings, different products, and demonstrate this methodology is a scalable, sustainable way to change your business.
Okay, I hope this answered your question, Herman. Okay, I think we have another, I think this is the last question because we're running out of time. So the question from Eub, is there any other possible reasons that IP production concerns that people still would like to keep an on-premise database rather than keeping working with only cloud?
I mean, this depends on different use case. For startup company, you don't want to invest a huge money or capital to buy many servers, build a team to manage infrastructure. Sure, you will probably go for cloud. But for people already have armies of data center IT staff, they're not going to fire these people and root it out. This move to cloud just simply for the sake of moving to cloud. I think a sensible decision depends on where it fits, right? Cloud is good for elastic, agility, and also for pay-as-go model, but it can be can be less secure, can be expensive long-term, right? So this is a balance. I think a sensible decision is you understand the cloud, you understand the on-premise, you understand your business and technical strengths and weakness, and decide accordingly.
Great. I hope you've just answered your question. Okay. Everyone is thanking you, and there's also a comment from Suresh. The algorithm I studied is 22 years. Okay, the algorithm I studied 22 years are now being implemented with cloud. It was challenging them, not anymore now. So this is just a comment. And yeah, so I think, yeah, we're a little bit extra time, and I think this is the time to wrap up. So there's a small poll a small survey for those who are still out with us. So please take a moment and answer a couple of questions about our webinar. And Andrew, thank you so much for doing this. We really appreciate your effort and your time for today. It was really interesting. It was informative. And I think a lot of our attendees, including me, got a lot of information from you today. And I hope you can share your slides, and we can post your slides in the details information as long as we provide YouTube videos. So yeah, I guess this is it. Thank you, everyone. Okay, thank you everyone for joining us. Thank you, Andrew, again. See you next Saturday. All right, bye.
Bye-bye.